In the late summer of 2022, a hauntingly beautiful, hyper-detailed portrait of a space opera theater took first place at a fine arts competition, yet no human brush ever touched a physical canvas. It was a digital apparition conjured from the void by an algorithm. This event shattered a long-held illusion that the chaotic, emotional realm of human creativity was an impenetrable fortress, forever safe from the cold logic of machines. We are now forced to confront a profound paradox. If a sequence of mathematical operations can evoke genuine awe, sorrow, and wonder in a human observer, what exactly is the unique spark of human artistic expression? For millennia, art was the exclusive mirror of the human soul, a testament to our singular ability to translate internal experience into external form. Now, the mirror is looking back, powered by unseen computational forces that do not feel, yet perfectly simulate the aesthetics of feeling. This is not merely a technological novelty, but a fundamental philosophical rupture. The algorithms behind AI generated art are actively rewriting the boundaries of imagination. They force us to ask whether creativity is a divine human spark or simply a complex pattern waiting to be decoded by massive, unfeeling processing power. The foundation of this creative revolution was laid with the invention of generative adversarial networks, or GANs, a class of machine learning frameworks where two neural networks are pitted against each other in a continuous, zero-sum game. Introduced as a radical way to generate realistic data, this architecture consists of a generator and a discriminator. The generator acts as a tireless digital forger, attempting to create images so convincing they pass as authentic. The discriminator plays the role of the art detective, analyzing the forgeries against a vast database of real human art, mathematically calculating the probability of deception. Through millions of iterations, this adversarial dance pushes both networks to extraordinary heights of sophistication. The generator learns the subtle underlying distributions of pixels that define a Renaissance portrait, a cubist landscape, or a photorealistic face. It does not copy existing images, but rather internalizes the arcane rules of visual composition, lighting, and texture. When the discriminator can no longer tell the difference between the human-made original and the machine-made synthesis, the network has achieved a terrifying milestone. It has learned to dream in mathematics. Yet, the echoes of adversarial networks eventually gave way to a new, even more powerful paradigm known as diffusion models. These models, which serve as the hidden architecture behind modern generative titans like DALL-E and Midjourney, operate on a profoundly different principle. They do not learn by forging. They learn by destroying and rebuilding. A diffusion model begins with a pristine image and systematically corrupts it, adding microscopic layers of digital noise until the original picture is entirely unrecognizable, reduced to a chaotic field of static. The true alchemy happens in reverse. The neural network is trained to carefully remove that noise, step by step, recovering the hidden structure beneath the static. By mastering this denoising process, the algorithm learns how to construct coherent images out of pure random noise, guided only by text prompts. In a fraction of a second, analyzing 5.8 billion parameters, the machine navigates an unfathomably vast mathematical realm. This latent space is a multi-dimensional map where every possible visual concept, style, and object is assigned a specific, hidden coordinate. Navigating this latent space requires an unprecedented map, one drawn from the collective visual history of humanity. The training data fueling these models consists of billions of images scraped from the open internet, encompassing everything from classical masterpieces and modern photography to medical illustrations and amateur sketches. The sheer volume of this data is staggering. It represents a digital distillation of human visual culture compressed into billions of parameters. The algorithms do not merely observe this data, but consume it, extracting the statistical relationships between words and pixels. This mass ingestion of human expression introduces a profound ethical friction. The unseen data streams fueling these emergent properties are built upon the uncredited, uncompensated labor of millions of living artists. When a user commands Midjourney to generate an image in the style of a specific contemporary illustrator, the machine is mathematically summoning the ghost of that artist's lifelong dedication to their craft. The algorithm strips away the context, the struggle, and the human intent, leaving only the statistical residue of the style ready to be endlessly replicated on demand. Consequently, a fierce battle over authorship and copyright has erupted across the digital landscape. Traditional legal frameworks forged in an era of physical media and human creators are entirely unequipped to handle machines that synthesize novel works from the fragmented echoes of billions of copyrighted images. If an image is generated by an algorithm, prompted by a human, and trained on the collective works of humanity, who ultimately owns the final output? The disruption of creative industries is no longer a distant theoretical threat, but an immediate, unfolding reality. The very definition of the artist is being aggressively renegotiated. As Dr. Margaret Bowden from the University of Sussex observed, artificial intelligence can produce novel combinations, but it is the human who must evaluate their cultural value. The human role is shifting from the physical execution of the medium to the curation of the machine's hallucinations. The prompt engineer emerges as a new kind of creative director. They wield language as a tool to navigate the latent space, coaxing specific visions from the arcane depths of the neural network. This shift forces a rigorous reevaluation of what constitutes art itself. Is art defined by the physical struggle of creation, the emotional intent of the creator, or purely by the aesthetic impact of the final piece on the observer? If a generative model can produce a breathtaking landscape that evokes a profound sense of melancholy, does it matter that the machine felt absolutely nothing? The digital arcane suggests that beauty and emotional resonance might not be exclusively human domains, but rather universal frequencies that can be mathematically tuned and broadcast by artificial minds. The bridge between our human language and these visual frequencies relies heavily on the transformer architecture, a deep learning model that adopts the mechanism of self-attention, differentially weighting the significance of each part of the input data. Originally designed for natural language processing, transformers allow the artificial intelligence to understand the complex, nuanced relationships between the words in a user's prompt. When instructed to create a cyberpunk cityscape at dusk, the transformer ensures the algorithm understands not just the individual words, but the atmospheric and stylistic context they create together, seamlessly translating human intent into machine action. However, relying on these statistical models carries a hidden risk of aesthetic homogenization. Because the models are trained to find the most probable visual representation of a prompt based on their training data, they naturally gravitate toward the center of the bell curve of human taste. This creates a distinct, hyper-polished aesthetic often recognized as the signature look of artificial intelligence generation. The bizarre, the truly avant-garde, and the deeply personal idiosyncrasies of human error are often smoothed over by the algorithm's relentless pursuit of mathematical perfection. This drive toward an optimized, homogenized culture touches upon a broader, more existential concern known as the alignment problem, the challenge of ensuring artificial intelligence systems achieve desired outcomes while avoiding unintended, harmful consequences. In the realm of creativity, this foundational dilemma is not about rogue robots taking over the world. It is about the subtle, invisible shaping of human culture by algorithms designed to maximize engagement or aesthetic appeal. If machines generate the majority of our visual media, our cultural evolution becomes tethered to the opaque optimization functions of a neural network. Looking further into the horizon, these creative algorithms point toward the looming shadow of the singularity, a hypothetical future point where technological growth becomes uncontrollable and irreversible, yielding unfathomable changes to human civilization. If artificial intelligence can already master the visual arts, music, and text, what happens when it begins to generate entirely new mediums of expression that human senses cannot fully comprehend? We are witnessing the birth of an alien intelligence, one that is learning to communicate with us through the universal language of art. To understand the magnitude of this moment, one must look back at the historical trajectory of artificial intelligence development. For decades, the field was dominated by rigid, rule based systems that could excel at logic and mathematics, but failed entirely at tasks requiring intuition or visual pattern recognition. The early AI winters, periods of reduced funding and interest due to unmet expectations, were largely caused by this inability to capture the fluid, messy reality of human perception. The current explosion of generative capabilities is the triumphant vindication of neural networks, proving that the architecture of the brain, when simulated at scale, can indeed capture the ineffable. The lessons from those early winters never faded, reminding us that progress is rarely linear, but often explosive when the right paradigms align. Today, we stand at the precipice of a new creative epic. The algorithms are no longer just tools, but mirrors reflecting the sum total of human visual history, compressed, quantified, and ready to be endlessly remixed. The future of art will likely not be a war between human and machine, but a complex, symbiotic synthesis where human imagination provides the initial spark and the machine provides an infinite, tireless canvas. Ultimately, the algorithms behind AI art force us to confront our own reflection in the black mirror of the screen. They strip away the mystique of the creative process, revealing the complex mathematical scaffolding beneath our most profound visual expressions. Yet, in doing so, they do not diminish the value of human creativity. Instead, they elevate it. In a world where flawless execution is instantly available at the push of a button, the true value of art will return to its purest essence, highlighting the unique, irreplaceable human perspective, the lived experience, and the bold intent to say something meaningful in a universe of infinite, generated noise.